So after the experiment is over, you have to do this kind of graph, and I will upload the same graph onto the Google Classroom, or you can follow the YouTube video where a link is given, that is according to the Google Drive. So once you click on the link, you will get that graph, or you can download it easily. And there is the calculation. So I am just verbally telling you the calculation part. So as you can see, the heading is there, that is the M, determination of standard reduction potential of Fe3 plus Fe2 plus system, and the strength of more salt. So these two things you have to find out: standard reduction potential of Fe3 plus Fe2 plus system and strength of unknown more salt solution. These two things you have to determine by means of this experiment. So here the calculation, first you have to start writing from this, that is 1 ml of potassium dichromate solution in burette is 18 drop, but you will do the drop count by your burette, that may be 16 to 19 drops. For my burette, that is 18 drop. Therefore for 1 drop, that is 1 by 18 ml, that is similar as like that of the pH or conductometric titration calculations. Therefore from the graph, as you can see, there is the graph, the equivalence point I got, that is 61, this is 61 drops. So 61 drops correspond to 61 by 18, that is 3.39 ml, approximately 3.3888 ml of dichromate solution, and strength of dichromate is given, that is supplied from the classroom, or that will be written in the blackboard once you do the experiment or once you come to the laboratory. Volume of more salt solution V2 we have pipetted during the experiment 10 ml. So by means of this easy formula, V1 S1 by V2 S2, V1 S1 is equals to V2 S2, you will calculate it. S2 is equals to V1 S1 by V2, where V1 is what? V1 is that value from the graph, that is 3.3888 ml. S1 is what? S1 is that value, strength of K2Cr27 solution, and V2 is the 10 cc of more salt. The final answer is 0.0440 of more salt solution. So the strength of more salt is 0.0440 normal at 22.5 degrees Celsius. Next, that is to be continued. The half equivalence point means the volume of K2Cr27, that is V1 by 2, you will get 1.7 approximately, which corresponds to E cell. You will get it from the graphical representation. So just multiply that value by 18 or the number of drops for 1 ml for your burette reading. Okay, so I got 1.69 multiplied by 18, something volume say corresponds to 0.415 volt, and once I get the value, just a moment, that is 1.69 multiplied by 18, I will get this value, that is 0.415, that is approximately 30.4 ml, that is 0.415 volts. So then that is E cell equals to 0.415 volts. So now again standard calomel electrode value is at 25 degrees Celsius 0.244 volt. Hence standard reduction potential of Fe3 plus Fe2 plus system is E half, that is 0.415. But your graph can vary. You will do it by your own. Once the experiment is over, you will do it in groups. Then that value plus standard calomel electrode, that is 0.244 plus 0.415, that will give you 0.659. Once you do a Google search, you will get 0.77 volt, that is near about 0.65. So my answer is correct, I think. And last, the conclusion is there. You can read it. And if you have further query, you may contact me or the other lab teachers. Thank you.